All right, and welcome. So today we are going to be continuing our conversation about input-output tables and graphing these linear functions. So first, please begin this do now, which is creating an input-output table for the following function, y is equal to 2 over 3 times x minus 3. So please create an input-output table and think about what types of numbers we're going to choose for our inputs or our x values, specifically because we do have a fraction. So please work on the do now and resume when you are ready to move forward. All right, so if you listen to my voice, that means you have worked on this do now. You have created an input-output table. The first thing that I want to identify is we have a fraction with a denominator of 3, which means we want to choose multiples of 3 when it comes to our x values. So I'm just going to pick a couple. I'm going to use 3, I'm going to use 0, and I'll use negative 3. What we're going to do is we're going to rewrite this rule, and we're going to substitute x to be the x value. Well, if we have 2 over 3 times x minus 3, we're going to substitute in the x value that we chose of 3. 2/3 of 3 is 2. 2 minus 3 is negative 1. Therefore, or y is going to be negative 1. If you chose 0, we're going to redo our rule. 2 over 3 times the x value we choose minus 3. It's a lot of 3's here. That's okay. We're going to substitute in 0. 2/3 of 0, or 2/3 times 0, is 0, and 0 minus 3 is going to be negative 3. And lastly, if we have the x value of negative 3, we're going to plug that in, or substitute that in, where we have been doing. 2/3 of negative 3 is negative 2. Negative 2 minus 3 becomes negative 5. And if you were to put these into ordered pairs, our first one would be 3, comma, negative 1, 0, comma, negative 3, and negative 3, comma, negative 3. And we would graph these, and we would create a line going through these points. And the reason why we want to do this is because soon we're going to be comparing different relationships and seeing, hey, which one makes more sense for us? Because we're graphing linear functions. We're graphing these relationships between these sets of data. We want to be able to analyze and say, hey, which one makes the most sense? So without further ado, let's talk about what that's going to look like. So let's talk about this situation here. Please copy down what you see in the top box, the box all the way up here. I'm going to remove that. It says a bicycle rental company charges a $25 deposit plus $2.50 per hour to rent the bike. Complete the function table and write and graph an equation for this situation. So this is a real life example where we have to show how much money we would be paying at any given time. But we need to come up with an equation first. Well, let's look and analyze some important pieces of information. Well, I see there's a $25 deposit, which means that that's going to be a one-time fee. So I know this deposit is going to be a one-time fee. So I'm going to write that. A deposit is a one-time fee. Awesome. Well, what else do we notice? Well, we also pay $2.50 per hour. So that amount is going to be dependent on how many hours we're renting the bike. Well, if I rent the bike for 2 hours, I pay $2.50 twice, or 2 times $2.50. If I rent the bike for 3 hours, well, I do $2.50 times 3, because it's 3 hours. So the second piece is going to be the rate. We call this our rate. And it's $2.50 per hour. And we can represent our hours with X, because we don't know how many hours it's going to be rented for. But we need to figure out how much it would cost if we knew how many hours it was rented for. So we can turn this into an equation. We can end up with the equation y is equal to our rate of $2.50 X plus that deposit of 25. And the reason being is that Well, we pay $25 to start out with. And then we're going to pay $2.50 on top of that. So we're going to be adding those two values together. And we've represented these with expressions before in chapter 1. But now we're just representing it with an equals y. That's the only difference here, is that we're going to have a y is equal to the expression that we have shown so much strength with in putting together in chapter 1. So now that we have our function, $2.50 x plus 25, I'm going to ask that you take this time now to complete the table below of hours, function, and cost, about how much it costs for each given hour. So all we're going to do is replace x with the number of hours in each time, as we have been doing with these input-output tables. And I'm going to ask that you try to create a graph with it. If you have graph paper, awesome. If not, just try to make a quick sketch of it, and please resume when you're ready to check your answers. All right, if you're listening to my voice, that means you have completed this input-output table, and you're ready to check your answers. Well, here is what our answers are going to look like. The equation, again, was y is equal to $2.50 x plus 25. In the function, we have it backwards a bit. We have 25 plus $2.50 x. That's totally fine. We're still going to get the same overall value because we have those properties of addition where we can flip the order and we still get the same answer. It's like saying 2 plus 3 is equal to 3 plus 2. You still get 5 both times. So for 1 hour, it's going to cost $27.50. For 2 hours, it's going to cost $30. For 3 hours, it costs $32.50, and for 4 hours, it costs $35. And we can create a line that's going to show this relationship. So as you can tell, a line was created on this graph. And we can use this to determine how much it's going to be at any given hour. So now that we have it within a function, well, we can plug in some numbers, or we can just look at the graph. If I were to ask you, how much would it cost for 10 hours? Well, we can look at the graph to determine that. We can look at the graph and find 10 hours and figure out how much money it's going to be for 10 hours. So please try that now. How much money would it cost to rent this bike for 10 hours? Yeah, exactly. It's going to be $50. And the reason we get this is we go to 10 on the x, and we can go straight on up and look at it and say, oh, well, it hit at that point, and at this point, if we go all the way over, it gets us to 50. So it's going to be $50 for those 10 hours, which is great. It's great that we can do it in one scenario. But what if we had another scenario that we wanted to compare? Let's say a second company charges a $20 deposit along with $5 per hour. So their deposit's a bit less, but they cost a little bit more of an hourly fee. So let's first create an equation. We know it's going to be y is equal to, and we need to figure out how much it is per hour and how much each deposit is. Well, if we read through it, it says a second company charges a $20 deposit. So I know this $20 deposit is a one-time fee. So it's only going to happen once. So I don't have a variable there because it's only happening once. So this is going to be my deposit, which again is a one-time fee. So I can fill that in my equation. Well, we also know that they charge $5 per hour. And I can represent $5 per hour by 5 times x. So I can fill in my equation of y is equal to 5x plus 20. Now that we have our equation, we can plug it into our input-output table to figure out how much it's going to cost for 1 hour, 2 hours, 3 hours, and 4 hours. So please pause the video and resume when you are ready to check your input-output table with our function that relates this real-life scenario. All right, if you listen to my voice, that means you have completed the input-output table and you are ready to check your answer. Well, if we know we have 5 times x plus 20 I'm going to fill all these in at the same time. That way it's a little bit quicker for us. The first scenario is we're looking at 1 hour. Well, PEMDAS 5 times 1 is 5, plus 20 is 25. So it costs $25 to rent for 1 hour. Trying to figure out how much it costs for 2 hours. So we do 5 times 2, which is 10, plus 20, which is 30. We're going to continue this process. Oh, that should have been in blue. Let me go back. Nope. Come on now. That's better. Well, 5 times 3 is 15, plus 20 is 35. And we have the 4 hour mark. So 5 times 4 is 20, plus 20 is going to be 40. So at 4 hours is going to cost $40. And you're soon going to be asked this question, which company would you rent from? And be able to defend your decision. So let's show a comparison between these two companies side by side in order for you to defend your decision. So on this graph, what I've done is I've taken the company 1 and we've copied that line in black. The second company that charges a lower deposit but a higher hourly rate is drawn in blue. So from this, I want you to decide which company you feel you personally would go with and be able to justify your answer. So please jot that down now. If you had to choose between company 1 and company 2, which one would you go for and why? So now that you've written down who you feel you would go with, let's talk about something that you might have noticed. Well, if we look right here, it looks like those two lines hit each other. They intersect. What does that mean in the terms of real life, though? Well, what's the hour at that? That's at the point of 2 hours. That's also at the point of $30. So that's telling us if we rented from company 1 or from company 2, if we borrowed for 2 hours, it's going to be the exact same price because they're both going to be $30 for 2 hours. So if you happen to rent for only 1 hour, well, which one is cheaper for only 1 hour? Well, if we look at 1 hour, which I wanted that to be in blue, come on now, that's now green. Goodness golly, Miss Molly. If we look at 1 hour, well, what has the lower cost? Company 2 in blue. 2 blue. Company 2 in blue is the lower cost. So if you were to choose between company 1 and company 2, you would want to go with company 2 because it's $5 cheaper. It's only $25 to rent for 2 hours with company 2. It would be $27.50 to rent with company 1. What if you were asked to see if you wanted to rent for 4 hours? Which company would be the better buy? Well, company 1 would be because it's cheaper than company 2. For 4 hours, it's going to be $35 for company 2. For company 1, I apologize. For company 2, it would be $40. So it would make more sense if you're going to be renting for longer than 2 hours to go with company 1. But if you're going to be renting for less than 2 hours, you would want to go with company 2. So this is how we're going to be able to analyze these real life situations with graphing these linear functions. And soon we're going to be talking about how to graph it in an easier setting. But this was a great job, folks. We're really proud of you. You were able to analyze some real life scenarios. You were able to make decisions based upon what was more cost effective. And you were able to apply it to what you might be doing in your life one day, comparing the price of certain companies and saying, hey, well, if I go for this amount of hours, it's going to be the same price. So it doesn't matter which company I go with. Great job today, folks. I'm really proud of you. Please jot down any questions that you have, and we'll see you soon.